music, or what is the physics of music, means how principle of physics is applied to music. So there will be many ways, but we will focus on one thing. We will focus on only this one. What is this? What is this? Can you read? Resonance. Okay. So what is the physics of music? Resonance, right? The application of resonance in music is called physics of music. So what happens when resonance is applied? Because of the resonance, or because of the application of resonance, there will be two things. Okay, two things. When I talk, that is not music. When many people talk, that is not music, right? That is not music, because there will be different frequency of the sound. When everybody, when every student talk in your class, will it be like a comfortable sound or uncomfortable sound? Uncomfortable sound. So that is like noise, right? Not music. Why that sound in the classroom when many students talk is not music? Because there are a lot of frequency of sound, correct? One student with one frequency, another student with another frequency, and they will be changing their frequency. So there will be a lot of frequency, correct, students? That is why it is not music, it is a noise. Can you change that into music? So we can change that into music by resonance. How we will change that into music by resonance? Number one, we will select some frequency. Okay, we will select some frequency, means selecting some particular frequency. Okay, or how will I write? Some frequency we are selecting, right? Or choosing some particular frequencies, some frequencies, choosing some frequency. For example, there are a lot of thousands of frequencies of sounds produced in the classroom. We are selecting few frequencies from that, a few frequencies. After that what we will do? After that we will make those frequencies louder, make it louder. Okay, for example, there are like a lot of frequencies of our sound. When I talk, there are variable frequencies, right? Variable frequencies. So my talking or my sound is not music. But when I use a music instrument, what that music instrument do is that music instrument select only some frequencies from my sound, and after selecting those some frequencies, and it will make those frequencies louder. Okay, it will make it louder, means it will amplify those sound. Yes. Frequency is pitch. Frequency is pitch. Okay, same thing. Frequency and pitch are same thing. Okay, you understand this, right? Okay, then what? Yeah, this one we did. Okay, one thing done. Yes. Then my next question: what is the meaning of natural frequency? natural frequency. Very good, excellent. Who said that? Okay, so every object has its own frequency, right? Its own frequency when it is doing a free oscillation. Oh, I can say frequency of a free oscillation. Frequency of a free oscillation. That is called its natural frequency. Natural frequency. So every object has its own natural frequency. Okay, every object has its own natural frequency. Every object has its own natural frequency. Okay, for example, this marker, and if I use a thread here, if I attach the marker with a thread, and if I let it oscillate freely, then it will oscillate its own natural frequency. Okay, so every object has its own natural frequency. So natural frequency depend on what? Natural frequency depend on what of the object? Natural frequency of the object depend on what? Yeah, try to say something. Very good. It depends on the mass of the object. Anything else? What did you say? Huh? Shape. Excellent. Very good. Shape. One more. Just give me one more. What is this? Size. So every object has its own natural frequency. Every object has its own natural frequency, and every object has its own natural frequency, and the natural frequency of the object depends on mass of the object, shape of the object, and size of the object. If you change the size, its natural frequency will change. If you change the shape, its natural frequency will change. If you change its mass, its natural frequency will change. Okay, then next, for example, yes, so I am standing here, so I will have a natural frequency, right? A natural frequency. If there is any object that is vibrating, and its frequency of vibration, if the frequency of the vibration is equal to my natural frequency, and when that object touch, then I will vibrate with a bigger amplitude. For example, this marker has a natural frequency. For example, its natural frequency, for example, okay, its natural frequency is 50 hertz. The natural frequency of this marker is 50 hertz, and this marker I kept on this table. On the table. Then I took my phone. This is actually a calculator, but okay, a phone, and I kept it in vibrating mode. I put the phone on the table. Then when the phone ring, it will vibrate, right? For example, if the phone vibrate at 50 hertz, if the phone is vibrating at 50 hertz, what happened? The phone is vibrating at 50 hertz, right? The phone is vibrating at a frequency of 50 hertz. So there is a matching, right? There is a matching of frequency. Phone is vibrating at a frequency of 50 hertz. that is equal to natural frequency of this marker, right? And phone and marker on the table. So what happens? The marker will start vibrating. The marker will start vibrating with a bigger amplitude. The marker will increase the amplitude of the vibration. Why? Because there is a matching of frequency. I hope you understand the meaning of resonance. Okay, what is resonance? Resonance is matching of frequency. The frequency of vibration of an object become equal to natural frequency of another object, then the second object will vibrate with a greater amplitude when they come in contact. Okay, students? Yeah, resonance is just you write the matching of frequency. Okay, I will write it later. Now you write the matching of frequency.
രണ്ട് പേജും രണ്ട് പേരിട്ടുണ്ട്. ഒന്ന് ഞാൻ വച്ച് ഒന്നതിലുണ്ടായേ ബീച്ചിന്റെ ഒന്നതിലുണ്ടായ.
Okay, so I will take water in this. We took water.
Starting here?
Yes. So here I will keep a tuning fork. You know what is tuning fork, right? Okay. Yeah. Yes. So what happens is like when we hit the tuning fork like this or with a rubber hammer, so it will produce sound. What is the difference between the sound produced by a tuning fork and sound that we produce? Any difference is there? Why we produce sound with a tuning fork instead of making a sound with the mouth, with our own mouth? For creating sound wave, we can create a sound wave with our mouth, right? Why do we use to control the pitch? Yeah, that is correct. So we can make single frequency sound, right? It will produce single frequency sound, one frequency. When I talk, when we talk, or when we make a sound with our mouth, the frequency will continuously change, right? Okay, one frequency, a frequency of 500 hertz. Okay, 500 hertz. Okay, and here we can see, here there is air column, right? Air column. The natural frequency of the air column is, for example, it's this much air column, right? There is an air column of this much length, right, students? Okay, so there is air. Okay, air I will just mark with this black color. So this is air particles. So air particle, now you can see this much is the length of the air particle. Okay, length of the air particle. We know that the natural frequency depends on the length, right? Depends on the size. Okay, means height of the air particle. Okay, then for example its frequency. Okay, frequency of this much, Natural frequency of this much air is 1000 hertz. All I am giving for example, okay? The values are not exact values, not correct values. Okay. So what are you doing? You make a sound with a tuning fork like this. So the tuning fork will produce a sound, and here there is air. Will the air make your sound, make the sound produced by the tuning fork louder? Will it make louder? You didn't understand my question. My question is, the tuning fork is producing a sound, right? What is the frequency of that sound? 500 hertz. And here we can see there is air, right? Air. So when there is a sound, the air near to that sound, air will vibrate, right? Air near to the sound will vibrate. So that my question is, will this air make this sound produced by the tuning fork louder? Will the air amplify the sound? Okay, but no, it will not amplify the sound. Why it will not amplify the sound? Because there is no matching of frequency, right? Frequency of the tuning fork is not matching with the natural frequency of the air. No matching of frequency. There is no matching of frequency means there is no resonance, right? There is no resonance. Okay, so we want to amplify that sound. We want to amplify that sound. So what we will do? I will do like this. To amplify that sound, I need to reduce the natural frequency, right? I need to reduce the natural frequency. How can we reduce the natural frequency? We can reduce the natural frequency by changing the size, because natural frequency depends on the size of the air column. So I will change the size of the air column. How will I change the size? Here I will make a tap here. Okay, will open the tap. When I open the tap, what happens? Some of the water will flow out. It will go out. So like that we are increasing. So I think the wavelength will increase, right? When the wavelength will increase, frequency will decrease, right? Frequency will decrease. Now frequency, for example, 700 hertz. Again you make the sound with the tuning fork. Will this air column amplify that sound? It will not. Why? Because frequency is not matching, right? What will you do? You will again open the tap. More liquid, more water is flowing out. Now the length of the air column increased up to here. Now its frequency is the natural frequency of this much of air is 500 hertz, for example. Okay, you again make a sound with the tuning fork. What happens? You will hear a very loud sound. Why? Very good. The natural frequency of the air in this tube is equal to the frequency of the sound produced by the tuning fork. Okay, so I hope you get an idea of resonance, right? Resonance in music instruments. Did you get a small idea about the resonance in music instruments? Okay. The next, we will talk about the resonance in closed pipe. Okay, after that resonance in open pipe. After that, resonance in a string. What is the meaning of closed pipe? Yeah, closed pipe doesn't mean both ends are closed, right? Closed pipe mean only one end is closed, other end is open. One end closed, other end open. Okay, so I will draw a closed pipe. One end closed, other end open. The length of the closed pipe, the length of this pipe is L. Okay. So here, how the resonance occurs? How the resonance occurs here, right? Resonance occurs due to the forming of standing waves, okay, stationary waves, standing waves. How standing waves are formed? Very good. When two waves meet, right? When two waves of same amplitude, right, and wavelength. When two waves of same amplitude and wavelength, there is one more condition, right, for the production of standing wave. When two waves of same amplitude and the same wavelength or same frequency, what is that next condition for the production of standing wave? There should be two waves. Those two waves have same equal amplitude and wavelength, and one more thing. Opposite. They must be traveling in the opposite direction. They must be traveling in the opposite direction. Okay. So those two waves are traveling in the opposite direction. When they meet, standing wave will be produced. So there will be, when they meet, there will be superposition, right? And you studied two types of superposition. What are the two types of superposition? Very good. Constructive and destructive. So in a standing wave, or in the production of standing wave, the formation of standing wave, if there is constructive superposition, what is the result? What is the result of a constructive superposition in a standing wave? Yeah, high amplitude. Very good. What is the name of that? No. In a standing wave, there are two things, right? Minimum amplitude or zero amplitude and high amplitude. What is the name of the 0 points of zero amplitude? Nodes and antinodes, right? Nodes and antinodes. So in a pipe will have one closed end and one open end, right? Open end and closed end. At open end, there will be always antinode. Okay. When a standing wave is formed in a pipe, antinode will be formed in the open end of the pipe, and node will be formed in the closed end of the pipe. Means closed end of the pipe will be always node, open end will be always antinode. Okay. Yeah. So this end must be node or antinode here. This end must be node because this is the closed end of the pipe. Closed end of the pipe must be node. And here what will form? Antinode at this end. So this end must be node, this end must be antinode. So the first possible wave is like this. Yes, Open end is antinode, closed end is node. Okay. Yes, yeah, not pressure, displacements of the air. Okay, we will talk in terms of the displacement. In the textbook they have given in terms of the air pressure, right? So we will talk in terms of the displacement. Okay, in the exam question I think they will give in terms of the displacements of the air. Okay, everywhere they give in terms of the displacements of the air. Okay. Okay, students, you know how to draw a wave, right? How do we draw a wave? We draw a wave like this, right? This is one wave, correct? So here you can see this wave, if I draw completely, it will be like this, right? Okay, so what is this one? This is a quarter of a wave, right? Yeah, 1/4 of a wave, a quarter of a wave. This is a quarter of a wave. So what will be the length of a quarter of a wave? What is the length of a full wave? Length of one full wave? Wavelength lambda, right? So length of a quarter of a wave will be how much? Lambda over 4, right? So its length is lambda divided by 4. Then we can write like this. We can write here. Here we can write L equal to lambda divided by 4, right? L is the length of the pipe, that is equal to lambda divided by 4. Why? Because only a quarter of wave is formed in that pipe. So length of that quarter of a wave, that is lambda by 4, it is equal to length of the pipe. Okay, is it clear? Okay, so from this equation, what is lambda? Lambda equal to, yeah, 4 multiplied by length. Lambda is 4L. Very good. What is the equation for? So this is the first possible wave, right? So we will call it the first possible wave. We will call it the fundamental wave. Okay, the fundamental wave. Fundamental. So this one is fundamental. Fundamental means first possible one. Fundamental wave. Okay, so what is the frequency of the fundamental wave? Means fundamental frequency. I will write f0. What is the equation for frequency? In wave equation, frequency is equal to 1 over time period. That is correct. In terms of wavelength, what is frequency? Very good. Only one student is telling, or all of you know? You know, right? Everybody know. Okay, so V by lambda. So fundamental frequency, that is equal to speed divided by what is lambda? Lambda is 4L, 4 times L, wavelength, correct. 4 times wavelength is equal to 4 times L, right? 4L. Okay, so this is the fundamental frequency of a closed pipe, not open pipe, closed pipe. Okay, then next one, for example, if you increase the frequency, then standing wave will not form. Okay, there will not be resonance when you just increase the frequency. Next frequency will occur. When the next frequency will occur, the length of the air column should be, this must be node, right? This must be antinode. Okay, this must be node, this must be antinode. So how will I draw the next frequency? This must be node, this must be antinode. Okay, this is the length of the pipe. Okay, so you can see this is a quarter of the wavelength, right? Lambda by 4, right? So what is this one? This one, half of the wave, right? Or I can make like this: 1/4, 2/4, 3/4, right? So I will write like this. Okay, here the length of the pipe now it is equal to 3 lambda by 4, right? 3/4 of a wavelength. Correct, students? Okay. So what is lambda? Lambda is equal to how much? Lambda equal to 4L over 3. 4L over 3. Okay. Then we will go to the frequency. The next frequency, it is the first after the first one, right? So we call it the first overtone or second harmonic. This is the fundamental one. Fundamental one is the first harmonic, first matching. Okay. Yeah, we call it overtone. That I will check. Okay, your question. The next F1, V by lambda, right? V by lambda. So V by lambda. What is V by, what is lambda here? 4L over 3, right? 4L. That over 3 I will write 3 here. Okay. Any problem? Okay, students. No, not okay, right? I think you didn't get that point. Did you get that step? Yeah, 3 was here, right? 3 was here. Denominator of the denominator, right? Denominator of the denominator will go to the numerator, right? Like that. Yes, it will give you the same answer. What is, yeah, this is just rearranging to get a structure. Okay, I will tell what is that structure. What is V by 4L? What is V by 4L? V by 4L is equal to fundamental frequency, right? Okay, so what is this? 3V by 4L, 3 times fundamental frequency, right? Okay, students. Okay, so for example, this pipe will not produce a lot of frequencies. Okay, this pipe will produce only some frequency sound. For example, this pipe is first producing a sound of 5 hertz. So that is the fundamental frequency, right? So what will be the next frequency or next sound produced? Will it produce a sound of 6 hertz? We cannot hear, right? 5 hertz. I will write 50 hertz. Okay, I will write 100 hertz. Okay, 100 hertz. The first sound produced. Then what is the next sound? What is the other sound produced by this pipe? Can it produce a sound of 150 hertz? 150 hertz? No, next sound will be 3 times fundamental frequency, right? So next sound produced will be how much? 300 hertz. Okay, students? Okay, from here, this step is clear, right? This step length is equal to 3 lambda by 4 is clear, right? Okay, so lambda is equal to 4L over 3, correct? Then what did I write? I wrote the frequency. What will be the frequency of this sound? Frequency is V by lambda, right? The basic equation of frequency. Okay, so here if I write this is lambda 1, then this is lambda 2, anything, leave it. So yeah, what is lambda here? Here lambda is 4L by 3. I substituted 4L by 3 for this lambda. Okay, so I got 3V by 4L. Is this step clear for everyone? Is this step clear? This step clear for everyone? This one? Okay, so my question is, what is this one? What is V by 4L? What is V by 4L? V by 4L is the fundamental frequency, right? V by 4L is the fundamental frequency, correct? So what will be the frequency of the first overtone? The frequency of the first overtone will be 3 times fundamental frequency, right? Then suppose if the fundamental frequency of this one, means the first sound produced by this pipe is 100 hertz, then what will be the next sound produced? Yeah, very good, 300 hertz. Okay, then what will be the next sound? No, 2 we will not get like this. How we will get 2? Because here this is 3/4, right? So we will not get 2. Okay, then next you can see, next will be 5. Okay, same pipe I will draw. The next will be 5. Here must be node, here must be antinode. So when I draw the next one, it will be like this. Like this I went, right? Correct? How many quarters here? 1, 2, 3, 4, 5, right? So here lambda is equal to how much? 4L by 5, right? It will be like that. Okay, 4L by 5. And what will be the frequency? Frequency will be, so I will write 1, 2. The next frequency will be 5 times f0, right? Okay, so here how much is the frequency sound produced? 500 hertz. So the this one, the means the principle of musical instrument is that it will produce only some frequencies. Okay, most of the musical instrument you can see with the pipe. So the pipe instruments will produce only some frequencies like this, right? And what those pipe will do? The pipe will produce only some frequency sound and it will make it louder. Okay, so open pipe done. Any question from this? Yes, correct. Means just to match the resonance, means just to make the resonance possible, so that only some frequencies will be produced, will be selected. And what happens? It will, for example, I am using the pipe. Okay, like this I am making sound using a pipe instrument. In my mouth, random frequencies will be going out of the mouth, different frequencies. what the music instrument will do? It will select only some frequencies and it will make it louder, okay, and it will make it like a music when there is combination of those frequencies. Okay, students, enough for today? Okay, we will continue in the next class. Open pipe and string we will discuss in the next class. So I hope you understand the closed pipe. Okay, you can read this. Okay, all of you read the notes. Thank you for joining. I'm ending the meeting. Okay, bye. Yeah, today I recorded.